Alright, question number 3. So this is for chapter 3. Okay, so for this question, we have to calculate the effective resistance. Okay, so that is very easy. So the EMF is given as 6 volt, and this cell here has an internal resistance of 0.5 ohm. Okay, so EMF is 6 volt, internal resistance is 0.5 ohm. Okay, so we have to calculate the effective resistance. So remember, if you are trying to simplify the circuit, simplify it towards the cell. Okay, so in that direction lah. So kalau kita punya mata di sini, gitu. So we are gonna start from simplifying it from here, and then after that here, and then after that here. Okay, let's do that. So first, it's gonna be this 2 resistor here lah. Okay, so I'm gonna label it as R1, R2, R3, and R4. Okay, so R1, 2 is connected in series. So how do we determine that it is connected in series? Is because these are not connected by any junction. So this is directly connected to each other. So that is in series. So series circuit, R1 is just gonna be added with R2 lah. So that is gonna be equal to 10 ohm. Okay, and then after that we are left with 1 resistor. Gitulah. Ada 1 resistor. So this 2 lagi kita tengok konon-kononnya. I think I have to draw it lah supaya tidak confusing. Okay, so we have the battery, and then we have the resistor kan. Okay, so resistor is here. Okay, and then we have another one. Gitu, and then tadi kita so simplify, so we are left with only 1 resistor here lah kan. Yeah, okay, so this is gonna be towards this here. Sorry about this part, you just have to skip. Actually, I can actually draw it beforehand kan, tapi saya tidak buat. Pablibat lah somewhere here. Gitulah kanan. Okay, so this one is gonna be here. Okay, so sekarang kita tinggal yang macam ni lagi. Okay, so this is R12, this is R3, this is R4. So we are solving these 2 resistors lagi. So if you look at this, at this point and this point, there is a junction here. So if there is a junction, this is connected in parallel. Okay, this 2 resistor is connected in parallel lah. Okay, so I'll label it as 1, 2, 3. So that is 1 over R12 plus 1 over R3, and to the power of negative 1. So you will get 5 ohm for this part. Okay, and then after that we are then left with only this circuit lah macam ni. Gitulah. Actually, I'm not gonna draw that part. Kita buat dia macam ni lah. Okay, tapi make sure kamu still nampak dia ada junction. Okay, macam ni. Macam tu. So, at this part here, there is a junction now between them. Okay, so that is a junction. So this is gonna be R1, 2, 3. This is R4. So if you look at this is again connected in parallel. So that is gonna be R1, 2, 3, 4. Yeah, actually, I'm just gonna write it as the effective resistance. Actually, no. We have a small resistor, internal resistance there lagi. Tapi ito kejap. So from this one, you are left with only R1, 2, 3, 4 equal to 1 over R1, 2, 3 plus 1 over R4 to the power of -1. So this one you will get 2.5 ohm. Okay, so then you are left with a small internal resistance here. Okay, so that is the resistor, and then you have the external resistor here. Okay, so now you have to add these two together lah. Okay, so this is small r, this is the 1, 2, 3, 4 punya. So these two are connected in series, so the effective resistance is R1, 2, 3, 4 plus dengan the internal resistance. Okay, so you will get 3 ohm as the answer. Alright, so that is Roman 1. And then Roman 2, we have to calculate the current through the battery. So that one, we are just going to use the EMF punya equation, which is I effective resistance. So this is similar to V equal to IR lah, okay? So we are going to use the whole effective resistance punya sebab we are looking at the EMF kan. So I is going to be equal to EMF divided by the effective resistance. So this is going to be equal to 2 ampere. Right, so that is on question 3A. Now let's look at question 3B. Okay, so question 3B is where you need to apply Kirchoff's rule lah. Okay, so whenever you come across a diagram that has loops, macam ni, there's one loop, this is the second loop, you are required to use Kirchoff's rule lah, because it's much more easier juga lah. Okay, so remember, the first thing that we need to do is look at a junction. So let's look at this junction here and draw the current going in and out of this junction. Okay, so let's look at I1. So I1 is going to be like this. So it is gonna be pointing into the junction. And let's look at I2 pula. So I2 is gonna go like this. Okay, so that is I2. And then let's look at I3 pula. So I3, remember current goes from the negative to the positive terminal current. Okay, so what I would do is I would just follow lah, terus dia lukis je direction current tu begini. Tapi there is not a problem if you want to draw it like that. You will just obtain a negative value telling you that the direction is in the opposite direction. Okay, right, so that is I3, this is I2, this is I1. Okay, so after labeling the current, what I would also do is draw the current direction for the resistor, for each of the resistor. Okay, so if we look at this, there is a resistor here, so I1 would be going like this. Okay, so this is the arrow, meaning that the current here will be pointing to the left. Okay, so this is current I1 juga. Okay, untuk 5 ohm ni pula, the current is pointing downward like this, so this is gonna be pointing to the right. So this is I2. Okay, so there's only 2 resistors. Now we have to determine the current for I3. Tapi sekarang ni tiada resistor number 3. One of my students tiba-tiba dia pergi tambah 1 resistor supaya ada current yang passing through, supaya current 3 ni ada R3 konon dia cakap. Tidak payah. So if resistor dia ada 2 saja, just stick to the diagram. Jangan tiba-tiba pergi tambah resistor. Alright, okay, so now we are going to apply Kirchoff's first rule. So Kirchoff's first rule states that the current going in a junction should be equal to the current going out of a junction. Okay, so if you look at this, current that is going in is I1 plus I2 equal to I3. So this is our first equation where we need to solve for I3. Okay, so next we are going to apply the second rule. Okay, so second rule, Kirchoff's second rule state that the total EMF is equal to the summation of the product of current and resistor. Okay, so now what we need to do is we need to designate a direction of the loop. Okay, so what I always do is I will always draw this arrow here. Okay, so if the direction of the loop is following this arrow here, it will be positive. Okay, so kalau kamu mau lukis ni nanti time exam, lukis mesti dari yang pendek ni pergi yang panjang. Okay, so this is gonna be like that, and then same thing goes for here. Okay, so what I want to do is I want the EMF for either one of this EMF to be positive. So apa saya buat? Saya buat the direction of the loop to be the same as one of this EMF. Okay, so saya follow yang inilah. So I want my loop to be going anti-clockwise. So that is here, and then here, and then here, and then here. Okay, and then this one pula, I will also do the same thing. I will follow this one. So, yeah. So this is pointing upwards, right, down, and left. Okay? Okay. Tapi kalau direction, kejap, we continue first. Alright, so the first EMF, I'm gonna look at the 6 volt punya. So 6 volt follows the direction of this EMF here. This is the same, so it will be positive. Similar to this 4 volt punya, this arrow is pointing upwards, similar to the direction of the loop. So we will add this 2, and then let's look at the resistor. So sekarang ni ada berapa resistor? Kita ada satu sahaja resistor. So there will only be one value di sini lah. Okay, bukan one value, one, ada satu je, tidak lagi tambah macam tu sebab there's only one resistor. Okay, so sekarang ni untuk resistor pula, cara kita tahu dia positive or negative is if it is pointing, if the direction of current is similar to the direction of the loop, it will be positive. Okay, so sekarang ni direction I1 is similar to the direction of the loop, so it will be positive lah. So 7 I1. So dari sini pun actually kamu boleh solve for I1, which is 1.43 ampere. Okay, and then let's look at the second loop pula. So untuk second loop pula, I'm gonna start with the 4 volt. So 4 volt, the direction of this EMF is similar to the direction of the loop, so it will be positive. Wait, let me just write this one. So it will be positive, so 4 lah. And then let's look at the battery here. So again, the direction of EMF is similar to the direction of the loop, so it will be positive. Equal, let's look at the resistor. Directly terus tengok the resistor. So sekarang ni direction of the current is also the same with the direction of the loop, so it will be positive. So 5 I2 lah. Okay, so from here we can also calculate for the I2, which is 2.4 ampere. Okay, so dari sini kita boleh sudah solve untuk I3, which is using this first equation. Okay, so I3 is equal to I1 plus I2 lah. So this is gonna be equal to 3.83 ampere. Okay, so if you get a negative value, which is negative 3.83, it is also accepted. You will also get marks for it lah. Okay, it just means that your direction of current is in the wrong direction. It should be pointing down lah instead of pointing up. Gitulah. Okay. Alright, so that is on question number 3.